everybody. This is Team Mogul Solutions, and we did our model presentation project on Mario Level 1. This was a project on GitHub created by two people, and it basically just recreates the first level of Mario. Gamers can use this program if they want to play the first level of Mario. So for this program, we chose the model view controller, and we wanted to explore this diagram because we wanted to see how someone would design a simple 2D side-scroller using this architecture style. And so as we were looking through the code, we came across, a couple stats. Like it's about 5,000 lines roughly, and it relies heavily on a add-on called Pygame. Also, we spent about 5 hours each on the project. Anyways, so to give a quick rundown of the MVC model, there's three parts: the model, view, and the controller. So the model contains the components of the program, and each component can have different states in it. A component could be something. Usually it's modeled as a class, so you have like a Mario class or a type class, and they'll have different states. For instance, a Mario could be running, or it can be falling, or it can be dying. And so the class basically keeps track of what state the model is in at that moment. Then there's a controller that takes input from the user, usually from the keyboard, and translate a key press into a state change of one of the models. And then the view queries all of these models and, using their states, gets the proper sprite and prints it to the screen. In this case, though, rather than querying whether a component has changed, it just takes every single component and prints it all to the screen from back to front at 60 frames per second. Next slide.
So this is the model part of the model view controller. And as Josh mentioned before, it has all the components of the system. These are represented as game objects. You would see like brick, coin box, things that you would see typically in a Mario level. Then you would see power-ups and enemies and Mario himself, and they're organized into these categories here. And over here in the bottom right, we would see state. And this keeps track of the location of all the different objects in the code. Like you would see that it keeps track of the location of the game objects on a coordinate plane on like the Mario level. And so that's how the state is kept track of. Now I will hand you off to Alex to talk about view.
The view section of the Mario program is split primarily into 4 different functions. The first function is the event loop seen in the top right, which listens for user inputs. So because of the view section, it doesn't process these inputs at all. It sends them as an event to the controller. But the view acts as the input and the output streams. The second function is soundmanager.update, which will ensure the correct song and sound is being played at any time. The third function is blit everything seen in the bottom right, which is used to render all visible components, putting them in the display queue, printing them back to front, so that way you can have a functioning screen working on a frames per second system. And the final function is pygame.display.update, which actually ends up printing the stuff, while blit everything just stores it into a display queue. The view section relies very heavily on Pygame, which is another open source application that we also partially analyzed to help understand this program. Basically the view section is best described as using a 2-tiered layered architecture, as Pygame is below it, and Pygame interacts with the operating system to make sure the game runs smoothly, while the Mario application never ends up touching the operating system directly, only operating through Pygame. Like with other model view controller implementations, the Mario game has to use the controller using only events. But there's a frames per second system, meaning that it calls an event inside of controller many times per second, in addition to the changes of key presses and if the application is closed with the event loop. As you can see on the right, we chose to show the source code for both the event loop and the blit everything functions, not the other two, because they are too simple or too complicated for this. The event loop listens for 3 types of events: when the application is closed, when a key is pressed, and when a key is released. It will reformat this into a way that's acceptable for the controller, so it can be used as a user input event. While the blit everything function will start by displaying the background image, following up with every single component in the order that it needs to be presented, and then finally it will write it onto the application window for the pygame.display.update to use. Now Brennan will be talking about the controller section.
The controller mainly handles updating all sprites in the engine, which is performed by calls to handle state. Handle state figures out where Mario is currently in the game, which affects all other elements in the game. Based on Mario's position and actions, every other part of the model which can change gets updated, such as bricks, enemies, and power-ups. The main loop updates every frame in the game, performing constant refreshes on the objects. From the view, the controller receives incoming key presses, which are translated into in-game actions. After updating, a proc call happens, telling the view that the information in-game has been updated, which causes the output to change based on these changes. The boxes of code in the slideshow show the results of given actions happening due to user input, changing the state of the game. The controller diagram on the left-hand side gives more context to how the main loop and user input events interact with the other aspects of the program. This is the end of our presentation.